Hey everyone, Russ here from the Reg team. Our next talk comes to us from GoDaddy security engineer Jon Wade. John's talk is titled Linux Incident Response, Windows of Opportunity. After the talk, there'll be a live Q&A with John. Just click the link that'll be displayed at the end of the talk and you'll be taken to the live Q&A channel. So have all your questions for John ready. John, over to you.
Hi, everybody. My name is Jon Wade. Thank you for joining me at CactusCon for Linux IR, Windows of Opportunity. A little bit about myself. I work at GoDaddy. I've been there for a little bit over the past decade. Primarily been a blue teamer, but I've worn some other hats as well, including threat intelligence and security engineering. I've been lucky enough to be involved in a handful of projects that receive public recognition. I look forward to continuing that streak. Outside of work, I'm a big horror movie fan, as well as a fan of artsy indie games. Favorite horror movie is the B-horror slasher Sleepaway Camp. My favorite game of all time is Shadow Colossus, though lately Hades has absolutely consumed my life. So what can we expect from this talk? Well, initially, this talk is for novices to intermediates and anybody who wants to get a better insight into what incident response on Linux looks like, as well as current open source capabilities that anybody can stand up within their own home lab. To make this content as accessible as possible, we're going to cover a simplified investigation methodology and how we can use that methodology to not only perform incident response, but also ensure we're ingesting the right data to get the job done. We're going to run through a scenario in which we work to identify what has occurred on a host. What will be covered? How tooling differs from Windows to Linux. The investigation method for dummies, simplified, to break down that process into easily consumable chunks. We're going to identify what data you need to perform basic investigation. We're going to briefly discuss the home lab setup that I created for this talk. We're going to discuss what does this malware look like inside that basic home lab, and how can basic logs and alerting tell you that story. And we're also going to do a short mention of why lsof is the best Linux triage tool and why you should stop using it. What won't be covered, we're not going to discuss much about how great Sysmon is. We're not really going to go crazy in depth doing an analysis of this piece of malware. We're not really going to do an in-depth walkthrough of responding to this as a full incident response incident. This is just the initial investigation. We're not going to discuss prevention in Linux. And we're actually not going to discuss the full setup of the home lab as far as how to do each piece here and there. I'll include a GitHub link later at the end of the talk with a ton of resources, the slides, everything that hopefully can at least get you started and kind of mirroring this setup. So what's the big difference between incident response on Linux and Windows? Really, it comes down to tooling. Windows Sysmon is exceptionally hard to beat when it comes to gathering operating system level data. AuditD can come somewhat close, but really the more data you pull out of AuditD and the more specific you are, the more performance issues you have. If you're working with OSQuery, for example, their performance tips actually suggest using AuditD as low as possible, filtering it more and more and more. And depending on what kernel versions you're on, changes what your options are for filtering. So if you're on an older CentOS host versus a newer Ubuntu host, there's a vastly different level of filtering that you can do there. PowerShell script logging is awesome on Windows, but on Linux, that's not really an easy replacement for doing Bash script logging, for example, or just Shell, or Perl, or Python. Any of that script logging, there's not a good way to do that in Linux. Managing security settings across the fleet of Windows is super easy. You standardize with GPOs. With Linux, there's you're almost spoiled by choice, but that just means that there's more ways to do it, but there's more ways to screw it up. There's more ways not to do it at all. So the reality is it's just a bigger hassle, it seems, for a lot more people. The other really big difference is the malware targets themselves. The vast majority of Linux malware doesn't directly target the user. You're not getting, ELF files in your email to download and click and open. Instead, the malware typically targets a vulnerable service that's exposed to the internet or what have you. Like I said, Windows, the huge majority of that malware is actually targeted directly at the user. The user's the big weak point there that they're going to have them execute and kick off that malware. So let's get into our simplified investigation flow. Luckily, the investigation between Linux and Windows is Same thing, same methodology. Nothing too specific here. There's a ton of great information out there from SANS, Mandiant, etc., that you can reference for how to perform incident response. We're just scratching the surface of one small section of incident response here. I personally prefer to dumb things down a bit when I'm introducing newcomers to investigations. And so I focus on these four main questions: who, what, when, and where. For most people, these questions are nothing new. We're going to use the relationship, though, to help you during your investigation to not get sidetracked. Make sure you don't miss important information by moving on too soon. Going forward in investigation, we're going to keep these questions in mind to help keep us on the right track. For me, the who, pretty simple. Comes IP addresses, host names, usernames, UIDs, etc. Ties it down to, I wouldn't say a specific person, but person is usually the best comparison there. What? That's kind of actions on intent. What happened? When? Pretty straightforward. That's a date, time. Where? That could be affected hosts. A little bit different than the who. Could be geolocation information related to IP address, but still different. So that gives you more locational data per se. And speaking of data, to be able to perform an investigation, you got to have data to start with. That's why when you start setting up any logging infrastructure, you need to take a moment to think about and plan out what data to ingest. Sending everything in the kitchen sink can actually be worse than not getting enough data in the first place. Particularly in an enterprise environment, those costs can skyrocket, add up very quickly, and cause you to actually not ingest what you need to in the first place. So if we take our simple questions from before and you review your log sources and answer those questions, do your logs help you answer the who? Do you have logs that show whether the action was successful or unsuccessful? Is there enough time information in the event? So for example, here we've got a nice Apache log. We've got the who, we've got a timestamp, so we've got the when, we've got a what, but more specifically, we have a status code. It tells us if it was successful or not successful. So in this case, we have that. That's great. But other things like application debug logs, a lot of times those are very low value. They a lot of times don't have timestamps. They don't necessarily have any information about who. Sometimes even the what is so vague it's hard to tell. So choose your data sources, closely and keep those questions in mind when you're picking them. The MITRE ATT&CK framework is really the best resource to assist you when you're attempting to map attacker techniques to a data source. So while the majority of the MITRE ATT&CK documentation and blogs are crazy heavily Windows centric, I think every single blog and even graphic like this one is probably going to reference Windows event IDs. That's obviously a challenge, but they do have a matrix specific for Linux that can help you prioritize what logs, or at least log type, to ingest based on technique. We're not going to cover much more about the attack framework here. There's a ton of really great talks that already exist out there. I strongly suggest when you go down this route, check a couple of those out. Those can help a ton. As far as our lab environment here, lab environment is going to be comprised of Linux hosts that we need to monitor, ensure that we have that we can answer our simplified investigation questions. Here I've broken down the questions a bit into what type of logs can help us answer the questions. For the who, as you probably expect, process execution and network connection logs can help us identify either specific usernames, IP addresses. For what, file system logs are a great way to show actions like file creation, deletion, renames, etc. When, luckily, it's a lot of the standardized logs in Linux, timestamps are everywhere. So that's pretty easy to solve for that. Where can be answered by not only which host these logs came from, but you can also, particularly through Elastic, enrich a lot of your IP data with GRIP, so geographically where these things may have occurred. To simplify our lives a little bit, we're actually going to be testing out Elastic's new Elastic security functionality, which they released to beta late last year. I think it was November sometime. The claim there is that they have one centrally managed agent that can provide you and pull off all of these host level information that you need. You don't need to manage file beat, magic beat, configs for each log you want to pull in. It kind of just does that for you. And there's a ton of other log sources we could come in, but the aim here is to answer those basic questions with as few bells and whistles as possible. Make this as accessible to everybody as possible, easy to set up as possible. So here's the very basic home lab setup that we've got. We have network segmentation set up for malware versus monitoring. That's going through a pfSense router virtual machine. So that manages the ACLs for us. Malware is only talking to what it absolutely has to talk to. Pretty straightforward there. The malware hosts have, like I said, the Elastic agent installed for the log collection. We also have OSQuery installed there in case we want to do any ad hoc information collection or things that we're not going to get from logs. Within Elastic Security itself, we're only utilizing the default detection set that they provide. We haven't created any custom or targeted detections, anything like that. And then everything you see here is open source. It's free. Guides are pretty easily accessible. For the monitoring side of the house, we're going to use some Suricata, some Zeek, OSQuery obviously over there. The whole thing is built on ESXi, so VMware. One of the biggest things people, I guess, seem to forget, snapshots of your friend. Take a snapshot, do something. Did it work? Did it not work? Cool. Roll back to your snapshot. Don't spend hours and hours reconfiguring something because you forgot to take the snapshot before you ran your malware. I also suggest building a lab. Don't just run the script that sets everything up for you. Build the lab yourself, at least the first couple times, because learning how it works and how to set it up, but more importantly, how to troubleshoot issues, where those logs should be, where the configurations of items are, gives you a ton of knowledge around how things work in Linux, how they should work, what's normal, what's not normal as far as the file system goes. But also, more importantly, it gives you the ability to kind of self-service your own playground. New tooling comes out, test it. Is it cool? Is it not cool? Does it have features you like that maybe, hey, if you have an enterprise, something else, suggest it to them. That was a big reason for me playing with Elastic here. It came out in November. I was super excited to be able to turn around and use that in my talk. So let's get to the main event, right? We've identified what questions we're going to attempt to answer, as well as what data sources we're going to use to answer those questions. So let's get started our show. Let's detonate a sample. In this case, we're going to be detonating something from the systemdMiner family. It's kind of an interesting family. I like it a lot. It's a bit unique in that its primary targets are typically, vulnerable and exposed enterprise services. It goes after Jenkins, Salt, Postgres, Hadoop, and other enterprise services. It's not going after your WordPress, your Joomlas. It's going after things that, in all reality, shouldn't be hanging on the internet at all. But clearly, there's enough of it out there that a whole family of malware exists. And on top of that, it does some interesting things once it gets going. So hopefully, that interesting behavior is something that we're going to look to uncover with the data we get out of the Elastic agent. To closely match this real-world scenario, actually, let me go back a slide and show you. My malware host, I've installed Jenkins. I've installed Postgres as well on there. Both of those are actually vulnerable versions. But otherwise, pretty much default config. Configuration-wise, I haven't tried to make that any more vulnerable than it is. So that's why, in this kind of real-world scenario, we'll execute our malware under the Jenkins user. Jenkins itself has a ton of remote code execution vulnerabilities and quite a few versions. So being able to execute a small bash script on a Jenkins host is certainly within the realm of possibility. So let's get started with some alerts. After executing our sample, we'll give it a few minutes to kind of bake. We're not just going to run it and then immediately stop everything. We're going to let it sit and do its thing for a little bit. And as we can see, we have a good decent number of alerts here. These are all the default detections, like I said. This detections view in Kibana gives us a pretty good view of information out of the gate. We get some who, some when, some where information. Jenkins username is called out. The Jenkins, Jinkies 01 host name for each event. So we've got kind of the who and the where pretty quickly. We also kind of have a pretty basic idea of what might be happening. We see some alert for proxy port activity, immediately followed by base64, encoding or decoding activity. So right off the bat, that tells me, I've got a payload that was base64 encoded that got pulled down from the internet and then decoded, at the very least. obviously there could be a lot more going on, but the 3-second view, I've got something to start with. So let's take a look at some of these processes, right? So there's the analyze button that kind of go into this view, so you can better see the relationship between processes. Here we can see that the sus process spawned a couple of bin.sh processes, which led to some further, base64 usage, as well as 2 instances of the chatter command or change attribute. Usually a tool which can provide you with this kind of bird's eye view can really help explain the relationship between the processes and what's actually happening, versus if you're just looking at the wall of text following parent PIDs and child processes. It can be a lot harder to quickly identify what the flow might be. If we transition over into Elastic's kind of timeline view here, we search for any activity performed by the Jenkins user. Let's narrow it down. Let's start with Jenkins for now. You can pretty quickly see there's, even just for the 12-minute period that this thing was running, we can, excuse me, we generate a ton of events. We can already identify that flow reserved in the analyzer view with the sus executable, kick it off bin.sh, which then forks to perform base64 decoding. Quite a handful of them here. You also get the command line, so you can actually see some of what might be echoed into base64 -d for decode. You can also see, files get created and deleted. You can see varlib Jenkins sus, that's our malicious file that we manually kicked off, deletes itself. So that's pretty interesting as well. So let's do actually a quick analysis of the base64 decode. I pulled it out of the data there, it was available. Just copy and paste it into Vim here so we can take a look at it. And then actually I did a quick base64 decode on it. I like to take notes, particularly stuff like this. Taking notes is super helpful. Always save them off, organize them. So the output of that echoed string into base64 decode is there at the bottom. We can clearly see your attacker attempting to remove the immutable bit. So that's going to be the chatter change attribute -i. The dash is actually going to remove the immutable bit. If it was a plus, it would have added the immutable bit. If you're not familiar with the immutable bit, it just means you can't change it. Doesn't matter if you root, doesn't matter what type of user permissions you have. If the immutable bit is set on a file or a directory, you can't do anything with it. You can't add to it, nothing. So it's pretty interesting here that our attackers are very specifically removing the immutable bit from that directory and then running a secondary command to remove the immutable bit from anything that might be inside the directory. Let's see. And then actually they check to see if the file exists, and they check to see if it does, remove it. They check to see if the directory exists. If it doesn't, they make it. So we already have actually some kind of, you can almost say IOCs here, right? That temp.x11 Unix would be a good IOC. If you're not familiar with that path, that's actually where the X11 Windows system writes its socket files. So that directory is fairly common, but typically you're only going to find 1 or 2 files in there, and that should be sockets. You're not going to find, data files or executables in there. That would be pretty highly suspicious. So if we dive further down the process rabbit hole, you kind of see all hell break loose here. There's a ton of fork processes, so much so that you can't even begin to see them all in the analyzer view. This is, like I said, the Elastic Security is actually still in beta, and this is kind of one of the challenges I've already run into. Is this is as far zoomed out as you can get, and this is not even close to being able to pull this whole thing into context, right? So the analyzer here is only showing, first whatever number of events here. But even if we could zoom out further, there was a further warning that this was only going to display the first 215 process events. So even if we zoom out further, we trick it and we get that feature request in, we're still not getting all the data. So that's something to kind of keep in mind as you're testing and using tools. What are the limitations to display a lot of data at once? Or is there a better way for you to chop that up into chunks? That's just something to be aware of. And it's also a great reason to test out stuff like this in your homeland, particularly if it's open source. Find out that issue before you really need to rely on it. Also, kind of interesting to point out here, the largest majority of these commands you're seeing, these are all kind of your generic built-in bash commands, right? Cut, grep. There's a couple of cron tab references here. Grep makes args, but for the largest part here, we're not seeing a bunch of executables dropped. We're seeing shell scripts being run here. From wherever earlier timeline and analyzer reviews, we saw some references to cron tab. We just saw it in the last image as well. In this timeline view, I've specifically bubbled up all of the file-related events, and we can see early on that a new cron tab for our Jenkins user was installed. So when you first go to modify our cron tab, we see this temp file created, and then we actually save that. Cron tab installs it into var spool cron tabs for the user, and that's actually where that gets written. So we can see the creation of the temp file and then the rename of the actual Jenkins file here. So this kind of answers one of our early questions of what, right? On Linux, if you're not familiar with cron, is your classic task scheduler. And much like its Windows counterpart, it is a favorite of attackers looking for a means of persistence. It's one of the most common persistence mechanisms on Linux, if not the most, followed up by creating a service, for example. So let's take a look at that cron tab, right? To revert cron tab, we're actually going to rely on the output of a OSQuery task. So one of the few things you can do with OSQuery is you can kind of set a series of questions to interrogate your system, and then have that output push to a file and ingest that into Elastic, right? So in this case, that's what we've done here. On the schedule, we say, hey, what's the cron tab for every user? Let's dump out the entirety of what it is, and we'll ingest it on a schedule. So this is the cron tab that actually got created for our Jenkins user. We can see it's going to run every day of the month, it's going to run constantly on the 20th minute of every hour, right? And it's going to run a shell script. If it has any output, it's all going to dev null. And it's running in the background. So it's a pretty interesting thing, but a super common for persistence, particularly with cron, that another shell script is written off and utilized. So like before, let's dig in a little bit. Let's do some quick analysis on this shell script. What's it trying to do here? So just like before, the top half here is what was actually in that .unixdb.sh, and then the bottom half is actually just the decoded base64. Right out of the gate, we can see our attacker is setting up some variables and functions to use later. We're not going to dig super deep here, but the key takeaways should be that you can kind of identify some of the functionality here, right? Our attackers specifically using DNS over HTTPS to resolve Tor SOX proxies. They're writing the word exit to a file named I, and then executing that and then removing that. That's kind of weird, but you have a very specific file name that we can maybe look at later. And then using that Tor SOX proxy that they identified previously, they're going to download and execute something that has a very specific file name. The file name is actually derived from the MD5 sum of the current date. So that's going to give us a pretty unique and long file name. So all the file names here, we've actually already seen in our timeline view in some previous slides. Specifically that I file we saw already. Definitely already saw references to temp.x11 Unix. This kind of leads us into yet another question. What exactly is that further file, that executable file that's going to get downloaded and run? What's it doing? So let's go back. Let's go back and see if we can figure out what's going on there. So luckily with their naming scheme, it's not too difficult to find a file name that's 35 characters. Not super common for those to exist in home directories for other users. Jenkins home directory, by the way, if you didn't know, is varlib Jenkins. That's another piece of OSQuery that if you wanted to, you could set up a task to pull that out. But okay, we can find that pretty easily here. Checking the analyzer view for the process, we can actually see that after executing itself, immediately deletes itself, and creates a file that, in a directory we're now pretty familiar with, that temp.x11 Unix. It actually creates a file named 22. Let's kind of continue down this what train of thinking to see if we can determine the purpose of this, executable. So with our network connection logs, I mean, these are all logs that are coming directly off that Elastic agent so far. This is nothing, this isn't a tap. It's nothing. It's directly off the agent. It's pretty easy to see some scanning activity going on here. So we've got our process executable there in the second column, and we're scanning. We're trying to connect to something. We're disconnecting. So not only are these all actually live hosts, but we're hitting the exact same port in every single one of them, and we're doing it pretty quick there. Almost that entire table is within the same second. If you're not aware, port 5432, that's Postgres. This malware family, very well known for scanning. That's how it moves laterally, but also how it finds new victims on the internet. So it's actually going to scan the local subnets first, and then continue on into the internet itself. In this case, I did set up that vulnerable Postgres machine. Surprisingly, the defaults are not vulnerable enough. Wasn't listening for every single IP address. Was only listening at localhost, so we didn't get to move laterally there. Kind of a bummer, but it does go to show that a lot of these vulnerabilities that take advantage of vulnerable setups like that, a lot of times that somebody's almost gone out of the way to make that thing more vulnerable. That's not a bad default config. That's somebody going out of their way. If we had seen this move laterally to that Postgres host, what we would have seen was been largely almost the exact same behavior on that other host. But let's take out this noisy scanning activity and see what other network connections, network activity we might be able to observe. Without the noisy scanning, it's pretty clear to see we've got a bit of curl activity. It's to both regular web resources as well as the SOX proxies that we mentioned earlier. The last entries here are actually kind of yet another unique executable. We can see the file name C8D9, whatever. Same sort of idea. Looks like it's going to be a 35 character kind of an MD5 scenario. But now we have another question. What's that doing? So let's, we have some more logs. Like I mentioned earlier, we got some Zeek, we got some Suricata, we have some additional network logs we can poke at. So let's look at those and see if we can determine if there's anything more specific that'll help us out here. So these are Suricata logs. Elastic and Suricata definitely had a fight for me. They refused to ingest them. So we're going to cheat a little bit. This is just directly out of fast.log. That's just the text file log that Suricata will spit out at you. This is the standard emerging threats open rule set. It's a pretty good rule set. There's a ton of rules. It's like 28,000. So just kind of be aware of, there might be a little tuning involved depending on what you have running on your network. But you can pretty clearly see here, hey, we've got curl, SOX proxy, identified that an ELF was downloaded, which is ELF is just the Linux executable file format. More SOX proxy, and then actually finally at the end we see cryptocurrency miner check-in. And if you backtrack, you can see that's that same IP, that 136.243.90.99 same IP. So we did finally end there with the cryptocurrency miner. In a perfect world, like I mentioned, Elk was Elastic wasn't really having me ingest these. They were fighting today. But in a perfect world, were these ingested, they would have displayed alongside the host-based alerts right there in the Elastic security section. That's how that is designed. So hopefully in the future, like I said, it's beta. Those things work a little bit easier out of the box, whether it's the agent or file beat or whatever, that just ships and works. So let's take a moment. Let's kind of recap what we've learned. We definitely rushed through that quickly, right? Normally you're not going to do an investigation in something like 30 minutes. You're going to spend a lot more time. But for the very, very basics of answering our questions, right? Our super simplified questions: the who, what, when, where. We've got our Jenkins user. We've got that Jenkins01 host name. What did we observe? We observed that the initial sus executable, handful of shell scripts. I got a cron tab configured. We had 2 uniquely named executables. We had scanning activity. We had crypto mining activity. When the timestamps from our logging shows that when this activity started, first alert started at 17:24. We actually continued to get alerts for another 6 minutes. And had we, allowed this to run even longer, once that cron tab hit, we've all started right back up again. Luckily, in this case, the where limited to just our Jenkins01 host. Like I said, we didn't actually move laterally to the Postgres host. We were lucky in that case, but very easily could have. And as far as some of the other interesting things that we saw, not necessarily related to the questions there, all those shell scripts were spawning a lot of children. And that's actually one of the challenges that we kind of observed here, because we don't have script-based logging, is if you're viewing this from the operating system level, you don't always have the context that those are all related in one shell script, right? So that's definitely a challenge, particularly for Linux. Ton of base 6040 coding, but that actually was a pretty good indicator for us that our attacker had a payload that they were pulling down somewhere, and decoding wasn't just one executable and that ran and that was it. There was a lot of actually pulling down additional payloads or modules. Like I said, the cron tab set up for persistence. I would say I don't think I've ever really seen an incident or attack where there really is no persistence. So that's something that I would strongly suggest. If you're getting stuck, if you don't know what's happening, there's a piece of the puzzle you're missing. Make sure you found your persistence. It's going to be there. Like I said, we had an executable drop for scanning. That one specifically was actually scanning for the Postgres. This family, like I mentioned earlier, can scan for a lot of different things, though. It can scan for vulnerable Jenkins, scan for vulnerable Salt, Hadoop, a lot of other enterprise things. We kind of got lucky that it was scanning for Postgres, because that's what I set up, but it could have scanned for a handful of other things as well. Then we saw the executable dropped for crypto mining. So I kind of promised you earlier, I tell you a little bit about lsof and why it's my favorite Linux command, and pretty much the only one you need to do initial Linux triage on an older system, not old system, but just on any system really. But it represents an older and a less secure way of performing any sort of investigation, right? Ultimately, you shouldn't be getting on a host directly to do anything. But lsof, still my favorite tool of all time. It can tell you, it tells you all open files on Linux. On Linux, everything's a file. So that really tells you everything. You can look at every process that's run by a user. You can look at every connection that's opened by a user, or every socket that's opened by a user. You can filter, out by user, by command. You can have it output just the PIDs, so you can just push it into kill. Super easy. Love it to death. It replaces PS, netstat, all the other things that attackers love to replace when they get on your box. Attackers always forget about lsof, always sleeping on it. So usually it's a great tool. But like I said, stop it. Don't get into the host to run your commands. You shouldn't do it. Move on. Consider using any other EDR command execution tool. Velociraptor is a great open source kind of EDR tool, similar to OSQuery, that has its own query language that you can gather data from endpoints. Alternatively, for quick and dirty command execution on a host, Salt and Ansible are both great options, particularly if you're already using them for your configuration management on Linux. You're doing that right. You can either run one-off commands, or you can create your own script to do what you need to do. So it's a great way to kind of do ad hoc commands. You don't have to get in that box directly. If we had hopped on this box and done lsof, this specifically is -p9. It's the one to look at all the connections, right? This is kind of the data that we would have seen. We can see that executable for scanning. It actually pretends, changes its name when you see it in the process list. But we can see here all the sends outbound that thing sent. Nothing connected. Luckily, I had ACL set up, so I'm not blasting the internet at large. So those are all just send, just waiting. And then the last one there is our crypto miner. You can see it's got an established connection to check in. I'm a super huge fan. I suggest everybody go play with it, but don't do it on a real host you care about. And that's going to be it for me, guys. I appreciate you all tuning in. I'm gonna get, like I said, I'm gonna get help. I'll be uploading a copy of these slides. So it's a nice list of all the resources I used or referenced while creating my home lab, as well as the other content for the talk. So feel free to check it out. Appreciate it. Thanks, guys.